this is not how you should do this in your classroom, okay? This is, and I don't know another word except grueling. Wu can talk from 8:30 to 12 without stopping if we let him, okay? And he will. So I'm just giving you some warning here.
Learning mathematics, as you know, the most important part is the details. If the details are not right, it doesn't matter how good it sounds, it's not going to work. And so I never actually had a chance to be able to talk at the Institute about the outside world, so to speak, what is actually happening, why you're here, and what's so important about what we're going to do. And this occurred to me for many reasons. I'll come to some of them. That maybe I should begin the Institute this time with a little general overview of what's happening outside so that you know why you're here. So we're going to learn mathematics, and now actually two people here, or two things here that also made me realize that maybe this is the right time to talk about something like this. First one is that I think there are at least 3 or 4 special ed teachers here. And the general misconception about special ed teachers is that, well, it's special ed, therefore you don't need to know too much mathematics, and not that important. It's all the special needs of the students that paramount. You cannot be more wrong than this kind of an idea, because if you know how to teach, I think you would know that, roughly speaking, you have to take it figuratively, the quality of the teacher plus the quality of the students must be bigger than a fixed number before it's going to work. Now, of course, by quality, it's not a number, but think of it as being good is very high and not good is very low, which means that if you have students who don't know too much, you had better be a very good teacher. But if you have students who are already very good, maybe the quality of your teaching is not that critical in order for good teaching to take place. And so for people who are in special ed, I think it's time to take the opportunity to learn it, and since you're here, and so you already agree with me. But it's also the thing that Dee mentioned a while ago, that she said to try to alert people to the need of professional development of teachers. And that is something that's very true, that most, so let me see, how many of you have had any kind of information about the Common Core standards in your own school district? Raise your hand.
Just what they are. Here they are.
No, I mean, do they get someone special to talk to you?
No.
So I myself, or you did, you know, Oakland did? Did they invited someone?
No, we've just been, well, Phil Darrow. So, yes.
Ross Valley.
Who's it?
Ross Valley, I'm no longer with it, but they had Phil Darrow out as well.
I see. Okay, I understand. Yeah, okay. Well, that's good. Now, that's a good beginning. But what I have in mind is not, first of all, you have to know what the Common Core standards are. But that's sort of like some pointing to the map and saying, well, this is where yours of A is. But the next thing is that you want to go there, right? So it's the process of getting that meaning. So in our case, that means what you really need is not only to know, that's the first step, preliminary step, but getting someone here to actually do something to help you to be able to implement the Common Core standards. And that, I believe, has not happened. And as Lee said, well, if it doesn't happen before 2014, you can pretty much forget about Common Core standards. And that's part of the reason we are here today. And so let me begin by telling you, So let me begin with a quote the playwright. How many of you have seen or know? I think it was made into a movie, wasn't it? Angels in America. Yeah. Did anyone see this? This is supposed to be one of the great recent plays in the last 20 years. So he was interviewed in a magazine about acting, and he had this to say: "Good acting training should be sadistic." You have to unlearn a lot of what you think you know about acting. And so now, come to teaching. And so I think what is true, an analogous way is that good professional development should make you unlearn a lot of what you think you know about school mathematics. The same thing. Now, of course, Kushner has something else in mind, and I have something in mind too. So what is it that you have to unlearn? So what you have to unlearn is what you have been taught. I don't know how it's impressive to you, what I just said. What have you been taught? Well, you have been taught certain things. As a teacher in mathematics, you have been taught mathematics in your K-12 experience. Then in universities or in colleges, you are taught certain things. But I would venture to get a guess that what you were taught in college has very little to do with what you have to teach yourself in the classroom. Anyone violently disagree with this statement? And that's the problem. You are taught certain things. What in K-12? What were you taught in K-12? Now I'll come back to that in a minute. But whatever it is, in colleges and universities, no one amplifies on what school mathematics really is, so that when you go back to teach, you will be teaching from a higher platform, knowing more, therefore you can do a better job. Better job than what you were taught when you were a student. Was that so bad? Well, that's not so bad. If what you were taught in K-12 was very good. Hence not to be very good, and for a reason that I come back to in a few slides. So let me give you some examples of what goes wrong with what is going on in K-12. I'll give you a series of examples. So they are by no means exhaustive. I can spend 3 weeks only talking about school mathematics, errors in school mathematics. And you don't want to tempt me because winning won you already. And I can go on. 3 weeks may not be enough. So let me just, in a limited time, let's look at some examples here. This is the first one. This is something you teach in 4th grade or 5th. Division with remainder, right? So this one, everybody writes this. Am I right or wrong? Okay. Have you ever thought about how bad that is? Mm-hmm. Yeah. What is this? What do you think this is? What? It's a number, 2 numbers, 3 numbers, fraction. What is it? So what is this now? 6R3. What is it? Clearly 2 numbers. Right? You have 2 numbers here. What is this here? Why are they equal? You're taught, you just swallowed it. I mean, this is what you're supposed to do. You ram it down your throats, and you're supposed to just gulp it down and so on. You don't think about it. Now, and then so, this is the right way to say it. This is what you mean. For this 7, there's no ambiguity about this. There's a number, that's a number. Are they equal? Try it. 24 plus 7 is 24 plus 3 is 7. Yeah, so it's equal. Something this simple, they got it wrong. So another way to say this is, so the conceptual thing about this completely wrong. That's probably not as obvious as this one, right? If that is 6R3, you agree this is 6R3, right? 6 times 11 is 66 plus 3 is this, right? Mm-hmm. So now if this is equal to that, if that's equal to that, therefore this is equal to this. Now, does anybody believe that? That that's equal to that? No, of course not. So that's one example, right? Let's try second one. So that we go on for a little bit about fraction, right? So what's a fraction? It's of course a piece of pizza, a piece of pie, or maybe some area in a rectangle or something, right? There's nothing wrong with that if you actually take it seriously. So let's see if you take it. Should everybody take it seriously? No, let's see. Should you take it seriously, then this is a piece of pie, that's a piece of pie. You want to teach students how to add, then you just say, that's a piece of pie, that's another piece of pie. Therefore, we have a way to manipulate addition of pies, and out comes the answer is 41 over 24. That would be perfectly good, by the way, so there's nothing wrong with that. provided you can actually implement that program. That with pies, we have special ways of dealing with them. But no, it's not how it goes. How's it go? Oh, you tell students. Never mind pies. Take the LCD, right? Now, students are confused the hell out of LCD because it's like because they don't know the difference between LCD and HCS. What was that? Highest common factor. Huh?
LCM.
No. Highest common factor.
Oh,
They confuse the two. The multiple and the factor. They can't keep them straight. And so you set up this hurdle, and then after that, then there's still no pie. No pie inside. You just say you do this, you do that, and then you somehow wiggle things, and then out comes the answer. So let me ask you. These were all written by adults. These adults were people who have never gone through a childhood. Because suppose you are a 10-year-old, you come to this. Addition to you is what? You count or you combine, right? So you say, so whole number, huh? You count and combine. So you think, you feel good, you spend a whole year learning how to add things properly, you come to fractions, you say, oh, that's a piece of cake because I know how to add whole numbers. So I learned this, right? So they try to learn it. What do you think they get? They get LCM and then this funny mixture, sometimes they call it butterfly method, whatever. And then out comes the answer. So if you're 10 years old, what do you think? You say, maybe I don't know addition. Now, if you don't know addition, what do you think you know about mathematics at that point? Zilch. Right? Do you want to go on? No, you don't. There's good evidence that math phobia starts here. And that's how we do the children. So you don't know what addition is. So next thing, multiplying fractions. So two pieces of pie, as I said, if you learn how to multiply pieces of pie, that's great. And you just say it, and that will be fine. But they don't. You say, when it comes to multiplication, you suddenly say, we don't want no pies. No rectangles. You know this algorithm, right? So the green thing is the unit, right? So that's the unit, that's another unit. So 5/4 is, you cut the unit into 4 equal parts, and 5, so this is the representing here 5/4. And then 2/3 is, you cut it horizontally into 3 equal parts, and you take 2 of them, right? And then, so now you see the intersection. So now suddenly learning how to multiply fractions becomes a pictorial venture. Draw your diagrams, and thou shalt find it. Right? Now, what has that got to do with a piece of pie? No. And secondly, which is more important? Okay, you can forget pies, provided this makes some sense. So what is it? Now you have to understand this in the context of what multiplication is, right? 5 times 7, what is it? There's no question about what is it. This is, multiplication is a shorthand to register adding the same thing over and over again. And it comes to this. What is this? What do you call this? How to multiply? What do you call this? Picture, drawing pictures, fine arts of drawing pictures. What is it?
Isn't that the area model?
What?
The area model?
Okay, so this is adventure in area, right? Okay, what exactly is it?
I don't know what that one is.
No, I don't mind. It's an adventure in drawing area. That's good too, provided you can say exactly what it is. What is it? You get intersection. That's fine. But how is intersection related to these numbers? What are you trying to say? Right? You say this is now the answer. Well, just suppose you get a fraction. What is a fraction? Piece of pie. How is this a piece of pie? So at that point you're 11 years old. Right? At 10 years old, you already gave it up. 11-year-old, when you're a year later, you come across this and say, And I not only have to give it up, I'm going to kick it out of my life, right? It has nothing to do with anything that makes any sense whatsoever. All right, so let's try next one. So now, you know this problem, standard problem. It's an algorithm. You must have taught something on this. I guess you were an elementary teacher. You know that has to be taught, right? Is this a standard problem? So, and now suddenly this pops up. Well, here is a crisis, right? It pops up. You have an algorithm to get an answer, which of course is 10 over 12. That's fine. That's not the problem. The problem is, what is our dealings with our fractions? It starts off with a piece of pie, then we detour to a rectangle. They come to buckets, no pies, no rectangles, only buckets of water. What are we doing? You're a kid, you have no way to hold on to this kind of reality. Right? So that's multiplication, right? So the next one, that's also standard problem, right? Let me see if you agree. You've seen it? Well, some of you must have seen it. Standard 6th grade, 7th grade problem. So you say, in that case, you tell them to divide. How do you divide? Well, you divide, you take in the fraction and invert and multiply, right? And at that point, clearly no point discussing this whatsoever. This is in the footlaw, just forget it. That's what it says, right? That's the kind of mathematics we're teaching our children. And then in college, you surely think somebody's going to right all the wrongs and tell you, well, don't do this and do it better this way and that way and so on, right? Were you ever taught that? Well, most of you were taught something. You have books. So they have lots of big volumes on mathematics for elementary teachers. But are they any better than this? No. Now you can vouch on that, I hope. But they repeat the same stories. So what are we doing?